Welcome back to Basic Biostatistics 2 to Session 7 Video 2. In this video, I'm going to show you how to run linear regression analysis and how to interpret the findings of the SPSS output window of the linear regression models. Linear regression analysis is a statistical model. As I probably mentioned in one of the previous sessions, in statistics we have two bigger groups of tests. One test that tests for differences between groups, two or more groups, and the other group of tests, they test statistical models. They try to see whether one variable can predict another variable, an outcome variable, or whether a certain set of several independent variables can predict an outcome variable. For linear regression or simple linear regression, we have one independent variable and one dependent variable. The dependent variable is the outcome variable, and the independent variable usually is the exposure variable. The assumptions are that the variables, both variables, the independent and the dependent, are normally distributed and their regular usually continuous. For instance, we would like to see whether body mass index can predict diastolic blood pressure of month 3. This means that any change in BMI, where this leads to change in diastolic blood pressure of month 3. We know that both variables are normally distributed and they're continuous, so we are all set in regard to the assumptions of the statistical test. Let us see now how to run linear regression models. We go to Analyze, we select here Regression, just right under Correlate, and we choose Linear Regression. Once we click on that window, a new window opens that consists of all our variables we know already on the left hand side, and the right hand side we have several different empty windows to fill in. The program tells us what's the dependent variable or where to add the dependent variable, and as we said, it's this diastolic blood pressure of month 3. We select diastolic blood pressure of month 3 and we move it into the dependent window. Now, under dependent, we have the independent variable. So what variable we try to have as exposure variables or as the independent variable? Well, we said it's BMI. So we scroll down and we select BMI, the continuous variables, the scale variables, as you see given here in the symbol, it's a scale. We move it into the independent variable. This is basically everything you need to do to run a simple linear regression model. If you go down to statistics, you click on the window, we can select other kind of information we may be interested in. I would definitely choose confidence intervals, as we're interested not only in the slope but also in the confidence interval. As you know, the mathematical equation of a line is the outcome variable equals to a plus b times the independent variable plus an error term. B is the slope, or how steep the line is. The bigger the b, the steeper the line. We click in continuous. You can check under options. You can select other kinds of value. This is more needed for stepwise regression models we're going to use in session 8. So you can omit that and click on cancel. Once we click on OK, SPS gives us 4 different tables. First of all, the first table tells us what is the variable entered or removed. This is also more important for stepwise regression models when you have multiple linear regression models, not only one independent variable, but several ones. It gives us a model summary. It gives an R-squared test. Now, as you will learn in session 8 about multilinear regression models, we have 2 ways how to evaluate whether we have a good statistical model. The first one is checking at R-squared. The bigger the R-squared value, the more complete a model is. The R-squared is the square value of R, the correlation coefficient. Values of R-squared value between 0 and 1, this is very close to 0. This means that we do not have a very complete model, meaning that BMI does not really explain changes in diastolic blood pressure. The second window is the ANOVA window. The ANOVA window tells us how efficient a statistical model is. You will see later on that the most complete model maybe is not the most efficient model. We're going to learn in session 8 how to choose between the most complete and the most efficient model. ANOVA gives us an F value. The bigger the F value, the more efficient the model is, and a P value, which is here 0.545, which means we do not have an efficient model. The last table we got, linear regression, is the most important one that gives us actually the answer to the whole linear regression model. We have the constant. As you know, the regression line is defined as A plus B times X. A is the same as the constant, so the constant will be 94.279. For BMI, for the row with BMI, we have the actual slope. So the slope is minus 0.086. That means that for 1 unit increase in BMI, we have a reduction of diastolic blood pressure of 0.086. This is not really much. And if you check the significance of that slope, we see that the p-value is 0.545, which is bigger than 0.05. This means that BMI does not explain changes in diastolic blood pressure, or BMI cannot explain variations in diastolic blood pressure, or that BMI is not a predictor of diastolic blood pressure. So if I know your BMI, I cannot predict how big was your diastolic blood pressure in month 3. SPSS also gives you the confidence interval, the lower bound for the slope, and the upper bound for the slope. As you see, it crosses 1, so not statistically significant. This is how you interpret the results of a simple linear regression model in SPSS. If you would like to write the final mathematical equation of a line, this will equal to diastolic blood pressure equals to 94.279, the constant, plus minus 0.086 times BMI. This will be the complete equation, mathematical equation of the line in our linear regression model. In the next session, when we talk about multiple linear regression model, we will go more into the depth of R-squared tests, of ANOVA tests, and how to check for completeness and efficiency of statistical model. In this session, the important thing is you know how to run a simple linear regression model, where to find the constant of the model, where to find the slope, and how to interpret the slope, whether the slope is statistically significant or not. Thank you very much.